Hai and Assalamualaikum warahmatullahi wabarakatuh. Salam UiTM di hatiku. Today we will present to you about technique of differentiation from the subject code of MAT183. But before that, let me introduce you to our member. My name is Farisha Nabilla Faizal, and with my teammate Putra Ammar Haqimi bin Azmi and one Azniza Syahira Binti Azhar. We are assigned to answer 4 types of questions in order to complete this task. So, without further ado, let's get right into it.
So, I will start first with question 1. Explain the meaning of differentiation and what are the techniques of differentiation. What is differentiation? Differentiation is a process in calculus used to find the rate of change of a function. The result of differentiation is called the derivative. So, why do we use differentiation techniques? Differentiation techniques help make it easier to find derivative, especially for more complex functions like powers, fraction, trigonometrics, or composite functions. So, what are the techniques of differentiation? So, as you can see here, we have 6 rules in this topic. We have constant rule, power rule, sum rule, difference rule, product rule, and quotient rule. So let's start with question 2. So we need to find dy dx for the following functions. In this example, we are asked to differentiate the function 3x squared secant x plus 2. Since this is a product of 2 functions, one is 3x squared and the other is secant x plus 2, we use the product rule. The product rule says dy dx equals to u multiply dv dx plus v multiply du dx. So we first need to define u equals to 3x squared, v equals to secant x plus 2. Then we need to differentiate each. Du dx equal to 6x, dv dx equals to secant x plus 2, then x plus 2. So now we need to apply the product rule. Dy dx equals to 3x squared multiply dv dx secant x plus 2 plus secant x plus 2 multiply dv dx 3x squared, which gives us dy dx equals to 3x squared multiply secant x plus 2 then x plus 2 plus 6x multiply secant x plus 2. So we arrange dy dx equals to 6x secant x plus 2 plus 3x squared secant x plus 2 then x plus 2. In this example, we are asked to differentiate y equals to 4x plus 2 divide cos x. Since this is a function in the form of quotient, a numerator over a denominator, we apply the quotient rule. Substitute into the quotient rule. Dy dx equals to 4 multiply cos x minus 4x plus 2 multiply negative sine x over cos square x. The final simplified form is dy dx equals 4 cos x plus 4x dy plus 2 sine x over cos square x.
Thank you Azniza for your explanation. Today I will guide you through solving a calculus problem using implicit differentiation. So here is the equation. We are given the equation y ln 3x minus e power of 2x plus 1 minus 10 for y equal to 0. Our goal is to find the derivative dy dx using the implicit differentiation. Okay, as we can see, there are 3 terms in the question. So for the first term, we need to use product rule. So given u equal to y and v equal to ln 3x. So to solve this question, we need to differentiate u and v. So when we differentiate u, we will get du dx equal to dy dx, and when we differentiate v, we will get dv dx equal to 1 over 3x multiplied by 3. Then we can simplify the question and then we will get 1 over x for the final answer. Okay, next, combine and arrange all the calculation we just do. into the product rule formula that has Azniza mentioned in the question 1. So after the combination and arrangement, we will get y multiplied by 1 over x plus ln 3x multiplied by dy dx. So the final answer, we will get y over x plus ln 3x dy dx. Okay, next for the second term, we need to differentiate the equation of e power of 2x plus 1. So what we need to do is we need to apply a chain rule. So what we get is e power of 2x plus 1 multiplied by 2. So the final answer, we will get 2e power of 2x plus 1. Okay, next we move to the third term, which is tan 4y. So what we need to do is differentiate tan 4y by using a chain rule. So we will get secant power of 2 4y multiplied by 4 dy dx, and we will get final answer is 4 secant power of 2 4y dy dx. Okay, so lastly is final calculation. What we need to do is we need to combine all the three terms that we have calculated just now into one equation. So we will get y over x plus ln 3x dy dx minus 2e power of 2x plus 1 minus 4 secant square 4y dy dx equal to 0. So next what we will do is we need to separate them, which is the equation that have dy dx will be put in the left side and the others on the right side. So the equation will be ln 3x dy dx minus 4 secant square 4y dy dx equal to negative y over x plus 2e power of 2x plus 1. After the separation, now we can calculate them easily. So we will get dy dx ln 3x minus 4 secant square 4y equal to negative y over x plus 2e power of 2x plus 1. And the final answer, we will get dy dx equal to negative y over x plus 2e power of 2x plus 1 over ln 3x minus 4 secant square 4y.
Thank you, Ammar, for the explanation for the question 3. Now, let's move on to the question 4. I will explain briefly to you on how to answer the question. So, for the question 4, we have to use linear approximation in order to estimate the value of root 4, 80.99 minus 2 over square root 80.99 correct to 3 decimal places. First of all, we can solve this question by using the calculator. By using the calculator, we will get 2.778 as the answer. So, this will be our expected answer for this question. Next, we need to find the fx. In order to find the fx, we can replace the value of 80.99 from the equation with the x, so that we get the root of 4x minus 2 over square root of x. Then solve the equation and we will get the answer of fx as x to the power of 1 over 4 minus 2x to the power of negative 1 over 2. After that, we need to find f prime x. In order to find f prime x, we need to differentiate the value of x from the previous slide, so that we will get the answer for f prime x as 1 over 4x to the power of 3 over 4 plus 1 over x to the power of 3 over 2. Next, we have to find the given value, which is x, chosen value, which is x naught, and the delta x. As I mentioned earlier, x is the given value, so we can find the value of x from the root, that is 80.99. For the chosen value, which is x naught, we will choose 81. The reason we choose 81 because 81 is the closest number to 80.99. Okay, now we will continue to find the delta x in order to complete this question. So, how to find the delta x? Delta x is the given value, which is x, minus to the chosen value, which is x naught. So, we will get the answer as negative 0.01. Next, we have to apply the linear approximation formula, which is f bracket x naught plus delta x equals to f bracket x naught plus f prime bracket x naught delta x. Then we just need to substitute all the value according to this formula. From the formula, we need to substitute the f bracket x naught. So our value is f bracket 81. But before we substitute this, we need to find this function first. As we calculate the value of f bracket 81, we will get the final answer as 2.778. Next, we will substitute the f prime bracket x naught. So, our value is f prime bracket 81. Same as before, we need to solve this function first. As we calculated f prime bracket 81, we will get the final answer as 0.0106. And the last step is substitute the value of delta x, which is negative 0.01 according to the formula. Then we should have solved the problem and find the final answer, which is 2.008. So, by using this method, we have proven that the value of 2.008 is same as our expected answer previously.
In conclusion, in this assessment, we explored techniques of differentiation. These 4 questions help us to define the slope of tangent using differentiation, define the derivative various techniques of differentiation, and define the linear approximation to a function at a point.